Hi, Assalamualaikum warahmatullahi wabarakatuh. In this video, I'm going to talk about the mean of a geometric random variable, and I'm going to show you guys how the mean is given as such. So mu is equal to 1 over p, and in order to prove this statement given here, we need these two results right here, which is what's geometric series and how do you find the sum of a geometric series. So first of all, let me just give you an example of geometric series. Well, this could be a geometric series 3, 6, 12, 24, 48, and so on. And the idea of a geometric series is that each of the sequence given here has a common ratio. So the common ratio here is 2. You can see that 6 divided by 3 is 2, 12 divided by 6 is 2, 24 divided with 2 is, 24 divided with 12 is, you get 2, 48 divided with 24 you get 2. So that's the common ratio. The common ratio here is 2. Also, you can actually express the series in terms of this one given here. AR, here we have 0, and then AR to the power of 2, AR cube, and so on. Okay, and based on this, we can see that this one is 3 times 2 to the power of 0. This one is 3 times 2 to the power of 1, so 3 times this value is 6. Next, we can have 3 times 2 to the power of 2, so 3 times 4 is 12. 3 times 2 to the power of 3, so 3 times 8 is 24. And here we've got 3 times 2 to the power of 4. 2 to the power of 4 is 16. 16 times 3 is 48. So that's how you can express a geometric series, where you can clearly see that this is the value of A, and this is the value of R. So here A and R. And if R is less than 1, okay, so if the absolute value of R is less than 1, this is the formula that you can use to find out the sum of a geometric series. But in this case, we cannot apply this formula because clearly the value of R here is greater than 1, okay? Now let's move on and look at what we're supposed to do, which is to prove that the mean of a random variable x, where x has a geometric distribution, is given by this right hand side that we've got here, 1 over p. And we're going to start our discussion with the usual starting point, which is to find what is expected value of x. So when you talk about the mean, you're talking about the expected value of that random variable, and we have already seen that this can be obtained by considering the summation process of x times fx. Okay, so what is fx? So fx is when it has a geometric distribution, the probability function is given by p times 1 minus p, and here we've got x minus 1. And we know that in geometric distribution, the values of x begins from 1, 2, 3, and it can go on indefinitely. Now, let us move on to defining what's the value of x here. So based on this, we can write down that x will begin from 1 until n. We can now replace fx with the function, probability function given right there, which is p times 1 minus p x minus 1. Maybe we can try and expand this process above, and we can write down, for example, if you substitute the value of 1 into x, then you will get 1 times p, 1 minus p, 1 minus 1. yeah, and then you continue substituting the next value of x, which is x equals to 2. So you've got 2 times p 1 minus p 2 minus 1, and you keep on doing it for several more terms. We go to 3, so 3 times p 1 minus p 3 minus 1, and then maybe we can go on for another term before we stop, just to see the pattern how it looks like. Yeah, so we've got 4 minus 1 plus dot dot dot, and maybe we can try and simplify what we've got here. So we can see that p here is the common term for each expression given here, so we can factor it out. Okay, so we're going to factor that out. We have p outside. Next, this one here is going to be 0, so 1 minus p is going to be to the power of 0. It's going to be equal to 1 really, so I'm going to write down the result here is 1 plus 2 1 minus p to the power of 1 plus 3 1 minus p to the power of 2 plus 4 1 minus p to the power of 3 plus dot dot dot. To make it simple, we can we're going to let q represents 1 minus p. So 1 minus p is 1 minus the probability of success, right? P here is the probability of success. Therefore, q here is really, it's just a probability of failure. So we're going to replace 1 minus p with q so that it makes things look easier. Okay, we just have one alphabet instead of dealing with 1 minus p. Therefore, our result here will become, therefore, we have ex, expected value of x is equal to p 1 plus 2q plus 3q squared plus 4q cubed plus dot dot dot. And I'm just going to call this equation as equation 1. Okay, so that's the first phase of trying to prove the mean is given as 1 over p. Now we're going to move on to the second phase. So in this second phase here, we're going to have to do a little bit of manipulation. Okay, what I'm going to do is I'm going to manipulate by having this equation here, and we're going to multiply this whole equation with 1 minus p. So the left hand side will be multiplied with 1 minus p, and the right hand side also will be multiplied with 1 minus p. So that's what we're going to do. Okay, so we're going to equation 1 multiply that with 1 minus p. Okay, so that's what we're going to do. Therefore, we're going to have e expected value of x times with 1 minus p. That's on the left hand side. Next, we got the right hand side is p, and then we have 1 plus 2q and so on. So we have 1 plus 2q plus 3q squared plus 4q cubed plus dot 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 will also be multiplied with 1 minus p, right? So on the left hand side here, we can write down the result as equal to ex times 1. So minus ex with times p. So we have e expected value of x times p. And then this part right here is actually q, and we can consider that we can multiply q with all the terms inside the bracket here. So that's what we're going to do. That's what I'm going to do. So we have p, this one, q times with 1, you will get q plus 2q squared plus 3q cubed plus 4q, and here we've got to the power of 4 plus dot dot dot. So that's the simplified version, and I'm just going to call this equation as equation 2. Okay, next, the third phase is we are going to have this operation where equation 1, we're going to have equation 1 minus equation 2. So we're going to do the next process, which is equation 1 minus equation 2. So if you look at the left hand side, we're going to have ex minus this whole thing. So it's going to be expected value of x minus expected value of x, this one. Okay, so we're just going to write down this part here. Okay, so that's what's going on the left hand side. And on the right hand side, we can see that okay, let me just write down the whole thing here. So here we've got all these terms, and we know that, for example, p here is going to remain. We're not going to do anything with it. Okay, so p here is going to remain right here. Next, what we're going to do is we're going to consider for example 1. So 1 minus, is there a number inside here? There's no number, so that means 1 minus 0, so it's going to be 1, right? Next, plus, okay, we're done with this part. 2q minus q, we can have that 2q minus with q, so it's going to be plus q. Next, we're going to have 3q squared minus with 2q squared, so 3 minus 2, it's going to be plus q squared. And then 4q cubed minus with this guy, so we will have q cubed. And of course here we have even though it's not written here, but we know from the pattern, we know there is 5q to the power of 4. Actually, that should be that we can use to minus with this term right here, so we will have q to the power of 4, and the pattern continues in this manner. Okay, so that's what we have. Okay, now I hope you can see that this part, ex minus ex here, will be cancelled out. Negative and negative here is going to be positive, so the result here will become e expected value of x times p is equal to p 1 plus q cubed plus q squared, sorry, q squared, q cubed, and then q 4, and we have this one, where you can of course see that p on the left hand side can be cancelled out with the one on the right hand side. So we have expected value of x is going to be the sum of something, and it continues, and these are actually a geometric series. This is actually geometric series that are being summed up. So we're talking about finding, so this part here is related to the sum of geometric series. Now, how do we know that this is a geometric series? Well, you can see that there is a common ratio. Of course, you can see the common ratio for this one is q squared divided by q. We're going to get q to the power of 3 divided with q to the power of 2. We're going to get q, so the common ratio here is q. You can see it clearly, right? And of course, you can also write the terms using this notation. So how does it look like? You can see that this one can be written as 1 times q to the power of 0. This one is 1 times q to the power of 1. This one is 1 times q to the power of 2. 1 times q to the power of 3. 1 times q to the power of 4, and so on. The pattern is like that. So we can see clearly that these numbers are geometric series, and we are having the process of summing up all these numbers. So we're talking about summing up the geometric series. And according to the result which I have shown you here, to find a sum of a geometric series, we can use this formula provided that our ratio has to be less than 1. Now in this case, our ratio here is Q. So our ratio here is the value of Q. What is Q? Q is the probability of failure. So here is probability. So probability of failure, and we know that when you talk about probability, the value is always less than 1, between 0 and 1. So in this case, we know that Q is going to be less than 1. So we can use the formula as given by this one right here, which is A over 1 minus R. Okay. All right, therefore, we're going to continue from this. Therefore, Ex, expected value of x, is going to be the process of adding all these geometric series. And we know that adding up all the numbers here, we just use the formula, which is A over 1 minus R. So what is A? A is 1. So A is 1. 1. And then this one 1 minus, what is R? R is Q. 1 minus Q. What is 1 minus Q? 1 minus the probability of failure, so that must be the probability of success. So we get the expected value of x is equal to 1 over b. So this is what we are asked to show or to demonstrate right here on this part. Okay, I think that's all for now, and I'm going to talk about proving the variance of x is as such in the next video. Thank you very much for watching.